Have you ever wondered what makes a lemon so sour, or why soap feels slippery? The answer lies in a fascinating corner of chemistry: acids and bases. Don't worry, this isn't going to be a complicated lecture. We're going to break it down so it's super simple and easy to understand. By the end of this video, you'll be looking at everyday items in a whole new light. So what exactly are acids and bases? Think of them as two opposite teams in the world of chemistry. They're all around us, in the food we eat, the products we use, and even inside our own bodies. To tell them apart, scientists use something called the pH scale. Imagine a ruler that goes from 0 to 14. This is the pH scale. It measures how acidic or basic a substance is. Right in the middle, at number 7, is what we call neutral. Pure water is the perfect example of something neutral. It's not an acid, and it's not a base. Now let's look at the first half of the scale, from 0 up to 7. Anything that falls in this range is an acid. The lower the number, the stronger the acid. So a substance with a pH of 1 is a much stronger acid than something with a pH of 6. What are some common acids you might know? Let's start with your kitchen. That's our taste in lemons and limes. That comes from citric acid. The vinegar you use for salad dressing? That's acetic acid. Even the fizzy bubbles in your soda come from carbonic acid. So when you taste something sour, you're likely tasting an acid. Stronger acids, the ones with very low pH numbers like 1 or 2, can be quite powerful. For example, the acid in your stomach, called hydrochloric acid, has a pH of about 1.5 to 3.5. It's incredibly strong and helps you break down the food you eat. It's amazing to think that your body safely contains such a powerful substance. Battery acid is another example of a very strong acid, and it's why you have to be so careful with car batteries. Okay, so we've covered the first half of our pH ruler. What about the other half? Any substance with a pH value from 7 up to 14 is called a base. You might also hear them called alkaline substances. It means the same thing. Just like with acids, the number matters. A substance with a pH of 13 is a much stronger base than something with a pH of 8. Unlike the sour taste of acids, bases often taste bitter and feel slippery to the touch. Think about soap. When you lather it up, it feels slick, right? That's a classic characteristic of a base. Baking soda is another common household base. If you've ever accidentally tasted it, you'll know it has a distinct bitter flavor. Other examples of bases include cleaning products like ammonia and bleach. These are strong bases, which is why they're so effective at cutting through grease and grime. Drain cleaners are also very strong bases, with a high pH, which allows them to dissolve clogs in your pipes. This is also why you should always wear gloves when using strong cleaning products. They can be just as tough on your skin as strong acids. So let's recap our pH scale. 0 to 7 are acids, 7 is neutral, and 7 to 14 are bases. Lower number means stronger acid. Higher number means stronger base. Simple, right? But how do we actually measure pH? We can't just taste everything. That would be incredibly dangerous. Scientists use special tools called pH indicators. You might have used one in science class before. Litmus paper. Litmus paper is a special strip of paper that changes color depending on the pH of the substance it touches. There are two types, red and blue. A simple rule to remember is this: acids turn blue litmus paper red, bases turn red litmus paper blue. It's a quick and easy way to see if something is an acid or a base. For more precise measurements, scientists use digital pH meters. These have a special probe that you dip into a liquid, and it gives you an exact pH reading on a screen. This is super helpful in labs, in swimming pools to keep the water balanced, and even in farming to check the pH of the soil. Now, here's where it gets really interesting. What happens when you mix an acid and a base? Do they just sit there? Nope. They react with each other in a process called neutralization. When an acid and a base mix, they essentially cancel each other out. The result of this reaction is usually just water and a type of salt. That's right, the same kind of salt you might put on your food is just one type of salt created in a neutralization reaction. The final mixture will have a pH closer to neutral 7. This is a really useful chemical reaction. For example, if you have an upset stomach from too much stomach acid, you might take an antacid tablet. Antacids are mild bases. They travel to your stomach and neutralize some of that excess acid, making you feel much better. That's neutralization in action. Farmers also use this process. If the soil is too acidic for their crops to grow, they can add a base, like lime, to neutralize the soil and create better growing conditions. So why is understanding pH so important in our daily lives? Well, our bodies are finely tuned machines that rely on a stable pH. Your blood, for example, has a very slightly basic pH of around 7.4. If it changes even a little bit, it can cause serious health problems. Our bodies have amazing systems to keep our blood pH perfectly balanced in our environment. pH is also critical. The pH of rainwater, lakes, and oceans affects all the living things in them. For example, pollution can cause acid rain, which is rain with a lower, more acidic pH. This can harm forests and kill fish in lakes by changing the pH of their water. That's why scientists constantly monitor the pH of our natural world. Even in our homes, pH plays a role. The pH of your shampoo can affect the health of your hair and scalp. The pH of your swimming pool water needs to be just right to keep it clean without irritating your skin and eyes. Let's do a quick, fun review. Sour taste. That's an acid, bitter taste and slippery feel. That's a base. What's the measuring stick called? The pH scale. What happens when you mix an acid and a base? Neutralization. You are practically a chemistry expert now. From the tang of a raspberry to the cleaning power of bleach, acids and bases are fundamental forces shaping our world. They're not just concepts in a textbook. They are active and essential parts of our everyday experience. By understanding the simple concept of the pH scale, you've unlocked a new way to see and appreciate the chemistry happening all around you, all the time. Thank you so much for joining me on this chemical adventure today. I hope you found it interesting and that you learned something new. If you enjoyed this video, please give it a thumbs up and don't forget to subscribe to the channel for more fun science explanations. Hit that notification bell so you won't miss our next video. If you have any questions or ideas for future topics, drop them in the comments below. Stay curious and see you next time.